So what I'm trying to do here, I will create a demo data for you. This is this data would be your RDD. Okay, so I'm using a Spark context. And all of that is in Spark context. So semicolon, if you're using or not, it will work fine. Same as a Python. And also follow the libraries in the Haskell. So also I'm providing to you this link we will provide to you. Also you can create your own notebook and you can try all of the examples. And test example which I'm writing here, this will be also saved over there. So you can log into it, and with the NMLS you can also log in. But we will create credentials afterwards. And you can do the practice here. So what I'm trying to do, I'm creating a RDD in this data. Okay, now I'm reading that file. JSON. Something here. The data set. So I'm loading that data. So let me do the same program in Scala here. Now I'm selecting first the data. This is creating an RDD of character. So let me check my data is here. Okay, so this is the problem. My data is not there in the proper format. So let's try another example. I will show you similar time that we have created earlier. So one is to download the Wikipedia and do the word count there. I can import that file to temp directory. Syntax mistake. Now I can access that. I can use HDFS URI like this, or I can use load directly. Some speed problems here. I'm loading that file, Wikipedia, and I'm doing flat map. So I told you why I'm using a flat map, because I have to collect all of the words. As you see here in Wikipedia, so every word are different here. So these are raw data, and we want to do the calculation. How many Java words are there? So I'm doing flat map. On the basis of space, I'm separating each of word, and then using a map to make a tuple with comma 1. So it will be a word, comma 1. Now I'm storing it to in memory, okay, cache. It's stored. Let me check my data. I'm using a take for doing the sampling. If I do the take 10, so it will get that data from only one RDD that have these 10 records. So it will take less time than collect. So I do have now the 10 words, okay, separated by the space. Now what I want to do, I want to do the count, word count. So use a double C as an alias for word count, and then reduce by key. So either you can use this one. This will also give you the result same. So it is not having the enough memory space. So it is not failing that. It is spilling out to your disk. Okay. You can also write reduce by key in this syntax, a comma b, where a is your incrementer. So here a value start with a 0 and b is your second value. So it will take for word, suppose I am taking for specific word is those. So it will first select that word and then initialize the accumulator, name is A here, and then increment by the value of B. B is the value of that. So word comma 1 we have values and it is providing me the word count correctly. Let me find out only the values contain Java filter. So A contain, this filter I have to use before map because this will become a tuple. Here I can use filter. Contain Java Let me check. I got some values over there. Yes. So I also have a row Java, JavaScript, and probably Java also. Let me count the values. How many values I have? So I think you got some basic idea how can we do that, because this was our assignment actually that I've given to you to do the word count and save to some file, output file. So now data is I have to store my word count. which contain Java. And also I want to count how many times word repeated itself. I can do directly. I don't have to use alias here. Save as text file. Now, just have to check its output. So follow the values stored in one RDD, or in one partition. That's why it creates the one output file. Now let me check what is an output file. See, so this is my output result, and the number of word count also there. So any doubt in this assignment, guys?
No.
Thank you, Kerry. Manisha, do you have any doubt in this assignment? Have you tried that?
No, Sudhanshu, I didn't try actually, so I'll try it, then I'll let you know.
I'm getting some problem with the dataset application on Zeppelin.
Okay.
I will try and then provide you that document. Okay.
Okay.
So if we are good to move now, then I will show you one Scala application. How can you build the Scala? Because this is a Spark shell. Okay. So this is I'm doing the interactively. But how can I create a standalone application in Spark, and how can I build that application with SPT? So SPT is I don't have any presentation of SPT, but I will show how it works. Okay. So SPT is a simple build tool similar to Maven and Ant. Okay. And for installation, it requires some steps that I will upload by end of the class. And it just run the SPT. That's it. Then it will open a shell of SPT. Then you have to write the compile and packaging of that program. If you want to compile that, you want to clean the old metadata informations. That means old ZAR files imported or in a cache, it is there or not. So you can also do that. And you can compile your program. You can do the packaging in a ZAR file, or in a var file also you can create with it. So it's similar to Maven, but specially built for Scala type of applications, Scala applications. So today we are going to build a stream application. So this shell is opened. I will write it here clean. So there is no code here because I'm running it on the root. There is no project here. Okay. So let me go to the project. Okay. So this looks like a project. Let me go to the root. And show you how a Scala program looks like. I will go through each of line so you get a better idea how a simple program look like. So this is a simple program. I'm doing just a parsing, the filtering, and then doing the map transformations over there. So only two transformation I've used. The rest of thing is the configuration part. So here I have imported. So these are important here because Scala context. If you open that Spark shell, so SC as a Scala context already there, already initialized. SQL context already initialized. See, SQL context available as a SQL context. So if I open there, so SQL context is already initialized. SC as a Spark context is already initialized. Okay. So, but here, if I am doing with the standalone application, I have to initialize. I have to provide all of the configurations which are required for this building this Scala application. So here is I'm importing a Kafka because I am creating a streamlined application with the Kafka. But here the most important one is the Spark conf, which is a configurations file of a Spark, and the Spark context, and all over the classes under the Spark context package. These are the streaming applications because that's why I'm using a streaming packages also I'm importing, and Kafka utils also. So this is a main important. So this is how you can create an object, a standalone. So object, if I am just provided object here in place of class, so that means it is a standalone application and it is a singleton class. I haven't initialized anywhere the audit string. Once I've created, it will automatically run. Okay, initialized. The singleton is single only one time initialized, and it can be used multiple times. I don't have to create again a new new initialization of that particular class or the string class. So this is a singleton class which we have defined with the object. Then I'm using a main function, main method here, okay, this is similar to a Java program also, and in main this is expecting some of arguments if you're providing, so that we will provide through a array of string, okay. And what is a unit here? So as we have done the Scala class, you probably know about the unit. Unit is firstly, after the column part is your output. So what would be your output of that main function? So unit can be anything. Unit is kind of an object in a Java. It can be your integer, it can be your string, it can be of any of type. So unit, that means of any of type. It can be your object just. So unit is equal to Java object. So I'm providing here configurations. I'm initializing configuration with a new method. And with a new syntax Spark configurations, I'm setting up my master. I have already told you we can set our master, that means our resource manager, yarn client, or a local machine, or Mesos. So if you are using a Mesos application, then you have to provide here a Mesos. If you are using a Spark application, your yarn as a resource manager, then you have to provide your yarn client. If you are using your local machine, because I'm not building I'm building a test application here, not on a production, so I'm using a local one. Here I am providing a set app name. So app name is the application name. So that I would be able, if suppose I am using a yarn one here, yarn client, how can I get idea which of application is running in my Spark history server, or in my how can I track that? So for tracking purpose, I'm providing a name of application. It is an audit string, and I'm also providing a listener port. So this listener port, this port should be not be used. So you have to check firstly and your port in the netcat, in the netstat. So all of the ports used in your server, you can see here. So my port should be not there, okay, should be not used by other applications. So it should be uninitialized, and I can provide the port here.
Yeah, so for every Spark program, we need to write the same configuration, similar type.
Yes, yes. So this configuration, if you are not providing here, you have to provide, because if you're not providing, suppose I'm missing out my set master, then it will automatically take yarn. Okay?
Okay.
It will automatically take yarn as a master, as a resource manager.
Okay.
Okay? So if I'm providing any of other resource manager rather than yarn, it can be a Mesos, it can be a local, then I have to provide it here.
Okay.
And this application name and the port, port is mandatory here. Application name, if you not provide, then it will automatically give you some name as a application underscore and some of strings as a unique name of your application.
Okay. So your object name and application name is similar. So is it a constraint to similar, or you can give any name?
The object name is and my application name both are different. Application name I'm initializing so that I can track on the resource manager, on a yarn UI, resource manager UI.
Okay.
So this is my yarn. If I'm not providing, okay, this is Spark shell application. I'm not providing any name here. Okay, so ID will be application underscore sum of string, which is unique.
Okay.
Okay, so this I can track. How can I track my application, whichever application is running? Suppose there are multiple Spark applications running over there. How can I identify audit stream is running over there? So this is how can I can identify with the name. This is the audit stream I have used, right?
Yes.
Else it will be a Spark application. That's it.
Okay.